Okay, I'm Saboor, and this is my presentation on passive and active transport. So, introduction. As we all know, our human bodies are very complex and made up of trillions of cells. And for these cells to survive, they must have a constant supply of vital substances and nutrients like water, food, oxygen, etc. The cell membrane is semi-permeable, and these nutrients need to be transported in and out of the cell constantly through the cell membrane. There are two ways nutrients can be transported, which are passive transport and active transport. So let's talk about passive transport first. The whole idea is to maintain external and internal balance. Passive transport is the movement of particles or substances across the cell membrane without needing any energy. There are a couple types of passive transport, like osmosis and diffusion, which we'll talk about. So, passive transport osmosis. Osmosis is the net movement of solvent molecules from a region of high water potential to a low water potential, equalizing the concentration on each side of the membrane, maintaining the balance. So, the water molecules are going through this protein and getting transported from a high concentration to a low concentration. So, normally particles in diffusion, which we will talk about, will go past through the cell membrane without using these proteins, but the water molecules don't do that because this middle part is very hydrophobic. So this the lipid bilayer and the phospholipids at the tail of it and the middle part where the tails are is very hydrophobic. So water particles will have a hard time, going through this. So they just use these proteins because it's easier for them. So if the water tries to pass through the cell membrane itself, the membrane would just be like, nah, get out. Anyways, diffusion. So diffusion is the net movement of solutes from an area of high concentration to a low concentration, going down the concentration gradient across the cell membrane to maintain balance. There's two types of diffusions: diffusion and facilitated diffusion. We call this simple diffusion too, but I just explained diffusion. Facilitated diffusion is some particles that are too big to pass. So in this is the high concentration, as it says, and this is the low concentrations, and particles are just going through the cell membrane into lower concentration to maintain that internal and external balance. Here, well, you can't tell in the picture, but let's pretend the molecules or the particles in this picture are bigger than these ones. If they're bigger, it's harder for them to pass through this because they're too big. So they use these protein channels to go from a high concentration to a low concentration. So comparison. So this is high concentration and this is low concentration. In passive transport, which requires no energy, it's going to go down the concentration gradient from a higher one, so from 1 to 2. And sometimes it requires protein channels, like for the water molecules, because it can't pass through the membrane because it's hydrophobic. And facilitated diffusion, particles are too big, so they use protein channels. Now, we're going to talk about active transport, which requires ATP, which we'll talk about in a second, and it's against the concentration gradient, which means particles will go from area 2 to area 1 because it's going to be against it, and it's always going to involve a protein channel. The similarities between these is that involves movement of molecules, both processes, passive and active transport, and it's the movement of those molecules across the cell membrane. So, active transport protein pumps. So as we talked about, requires ATP. So ATP is, I'm not going to try to pronounce this. You might take my marks off, so I will not do that. But this is basically the energy currency of the cell. And this process, active transport, always requires protein pumps or carrier proteins, as we can say. So it's against the concentration gradient, and it always involves a protein channel. So active transport basically moves particles against the concentration gradient, which means against where they would normally want to go. Like normally, it would want to go from a high concentration, as it says right here, to a low one. But sometimes it doesn't want to do that. In this GIF, for example, or in this picture, what should happen is diffusion, high concentration to a low concentration. But sometimes cells want to keep stuff inside at all times or outside at all times. So it pulls or pushes the particles out or in against the gradient, and that's why it requires energy. So the main comparison between passive and active transport is that if they would require energy or not. There's two types, endocytosis and exocytosis. This is endocytosis. In endocytosis, ATP, which is the energy, is used for the cell membrane to fold in, like it's folding in, it folds in and makes a pocket around the materials it wants to take in the cell. And then the pocket then breaks loose from the outer part of the cell membrane and forms a vacuole within the cytoplasm in the cell. And large molecules, parts of cells, or even whole cells are transported or taken in the cell this way. Exocytosis. This method is kind of the opposite of endocytosis. It is ATP, which is the energy used for vesicles to transfer materials to the cell membrane and fuse with it to get materials outside of the cell. So it's the opposite of endocytosis. So when the cell produces substances for export, like it could be protein, or when the cell tries to remove waste or excretes waste, it goes through exocytosis. Why do we need both? Active and passive transport are very important processes where nutrients are transported outside and inside of the cell. Some nutrients are small and easily pass through the lipid bilayer, but some are big and they need other ways to get transported. Ways that are against the gradient or need energy because it's against the gradient. That's why we need both. For example, Miss Collins needs a Saboor in the class. A class is incomplete without Saboor. Without me, she would not have fun in the class and it would be all boring. Anyways, some processes happen naturally and they don't require energy because it's less effort, and some need energy because it's more effort. So, in conclusion, both active and passive transport works for a similar cause but with a different action. Yeah, that's it. Thank you very much. I will gladly take a 90 plus.